Alright, this video is meant to help you with what are called arithmetic sequences. And an arithmetic sequence is just a sequence that has a common difference, or basically to get from term to term, there's going to be a constant growth, or sort of like a slope almost. Again, go from term 1 to term 2 to term 3. You're going up by the same amount every time, or possibly down by the same amount every time. So you'll notice the sequence on the left is a good example of that. To get from 3 to 11, we would essentially just add 8. So we would go from here to here by saying add 8. Well, to get from 11 to 19, we could also add another 8. From 19 to 23, we could add another 8. So we're just adding 8 each and every time, which is again what we would call the common difference. Now another way to look at that is, if we go from term 11 to term 3, you're really subtracting 8. Or basically, again, why we call it a common difference. Typically in math, a lot of times we'll take the second number minus the first in order to help us find sort of how things are growing or changing. So let's look back here real quick and we'll look at a few different formulas that you can use for an arithmetic sequence. Then we'll go show you where each one is sort of to your advantage as far as using them. So the first and foremost nth term explicit formula, as we say, to be able to just plug in terms and find each and every term without having to base it on a previous term, is that a sub n is equal to the common difference between each term, or essentially kind of like a slope, multiplied by which term we want to find, plus, again, sort of a constant. It's sort of what we're offset by. If we were thinking of this as a linear equation, because arithmetic sequences are very similar to linear functions, d would essentially serve as the slope, the rate of growth, n would have been our variable x, or essentially we're plugging in a sub n, we're plugging in that changing number at our variable, plus c, which would essentially serve as our y-intercept, or sort of that first step, and then from there we change, right, given our variable and our slope. To find the common difference, again, we could always take a sub n plus 1 minus a sub n, or basically any term minus the term before it. C is really equal to the first term back up one more difference. And again, we can point that out on our next screen again. If we wanted to find the C value, what we would essentially do is take our first term and back up one more step. Because if this is term a sub 1, then we really want to find term a sub 0, sort of like our y-intercept when x would have been 0. So let's start off. Let's go ahead and find a few of these things. So 3, 11, 19, and 27. First thing I need to know is my common difference. So again, a good idea for that is to take a term minus its previous step. So kind of like we did up top, 11 minus 3 would have equaled 8. So that's going to be my common difference. Our C value, again, is just taking the first term, so 3 minus that common difference one time, or essentially we're going to start from negative 5, even though that would have been previous to the terms we have. And if I want to set up my formula then, I can take my common difference, 8, times n, whatever step I'm on, and minus 5, because that's essentially where we were starting from for a y-intercept. And we could double check that with any given term. So if 27, again, is going to be term a sub 4, if I plugged 4 in here, 4 times 8 would be 32, minus 5 would have been 27, and that's exactly what we wanted to get for term a sub 4. Now, if we go over here, we can use a few of those values to try to help us with the arithmetic sequence on the right. Notice we have term a sub 1, and we have term a sub 2, 5 and 13. We want to find term a sub 10, but again, that's pretty far down the road, so I'd like to be able to just plug in 10. I'd like to come up with an explicit sequence again in order to be able to just plug in 10 and find my answer. First thing we should start with is it says it's arithmetic, but let's double check, or we'll kind of trust that, I guess. Let's find that common difference then to help ourselves out. Well, any term, so term a sub 2, minus the term before it, a sub 1, should be one way to get our common difference. So if we took 13 minus 5, the difference to get from one step to the next essentially became 8. Well, now our other sequence would be helpful because we could go find that C value. We are on term 1, so we could back up and find that C value if we wanted to, set up a sequence, and then plug in 10. But another helpful sequence, maybe this one down at the bottom, if we take any term, or a sub 1, our first term, to get to any term after that, we just want to add the common difference. The only question is how many steps along the way do we want to go. And what that tells us is that a sub 10, since we want to get to step 10, if I take a sub 1, or 5 right now, and add on my difference, right, because I essentially just want to add 8, add 8, add 8 to get from step to step, I'm going to do that 10 minus 1 times. And what that's basically saying is I'm already on a sub 1 right here. And it's like being on a staircase. If I'm on the first step, then I only need to take 9 more steps, right? 10 minus 1, in order to get to step 10. I'm already on the first step, so I don't need to do 10 full steps. Well, 5 plus 8 times 9, or 72 plus 5, would be 77, and that should be a sub 10. Now, occasionally they may give you some more terms here, but notice this time they did not give us a sub 1 and a sub 2. So that previous formula may not be the most helpful one this time. In fact, let's take a look at our formulas. Our recursive idea of getting from one step, adding on the common difference to get to the next, isn't a bad plan, but notice that our two terms aren't directly consecutive. They're not one after another. So I'm not going to be able to go from one step directly to the next step. I've got a whole bunch of steps in between. So that formula is probably not going to be that helpful. A sub n equal to our first term again, plus the difference, might be a little more helpful. But again, the problem is I don't know a sub 1. So I'm going to kind of rule that formula out as well. But another formula similar to that is basically saying to get to any step, a sub n, well, really I could start anywhere on my staircase. I could start at any step. I don't need to be on step 1. I could be on step x. And from that step, then I just need to add the common difference to move to any future step, or technically any previous step. But I need to know where I'm starting, and I need to know how many differences to add or subtract, right? And that's what this n minus x is doing. How do I get from term x to term n? How many steps do I need to take? Well, let's try that formula out. If I plugged a sub 13 in on the left, and a sub 4 in on the right, I'm going to add the common difference, which unfortunately right now I don't know yet because I don't have two consecutive terms. But I can say that I'm on step, or I'm looking for step 13, starting from step 4. And basically, if I plug in what I know, 67 will be step 13, 22 is step 4. Again, I don't know the common difference, but I do know they're 9 steps apart, 13 minus 4. If I subtract my 22, this would be 45, and divide by 9, I know that my common difference then is 5. So if I want to go back and find a sub 1 then, I can start from any step I want. So why not start at step 4, since I know the value of that? I'm going to add my common difference of 5, and I'm going to take, again, I want to go from step 4 to step 1. So I'm going to say, to get to step 1, minus 4, there's the difference between them. Now that's going to seem a little weird, because even though step 4 is 22, I'm actually backing up 3 steps. So it should make sense that we got a negative 3 over here. I'm going to go 3 steps previous to where I was. I want to get from step 4 back to step 1. So a sub 1 is really 22 minus 15. Or basically I need to back up, right? To get from 22 to 67, going forward we were increasing, but to go backwards, we're technically going to decrease. A sub 1 must have been 7. And then we added and added and added and ended up at 22 here. Now, we could repeat that process for a sub 2 and a sub 3 if we want to. Or, now that I know a sub 1, again, I could go back to my formula that was up here, right? If we'd like to, because now I know that to get a sub 2, I really just need to take a sub 1 and add the common difference 2 minus 1, or 1 time. I need to move 1 step. And in fact, again, that's what this other formula up here is also getting at. Up top, the fact that really 2 minus 1 is just 1, So if I really want to just take a sub 1 and add the difference one time, a sub 1 will get me to a sub 2. Or that a sub 2 basically would have been a sub 1, or 7, plus the difference of 5, and a sub 2 equals 12. To get a sub 3, I need to take a sub 2 plus the difference, or basically take 12 plus 5 and get to 17. And again, if I added 5 one more time, that should get me to a sub 4, which would have been 22. Again, this formula down here at the bottom is more of a general formula. If you take any step along the way, a sub x, and I add the common difference a certain number of times, right, n minus x, the number of times that it would take me to get from x to n, I can get from any term to any future term directly. Again, hopefully that made sense for you. Again, feel free to watch the video again or practice a little bit. And if you have any questions, make sure you refer to your teacher. Otherwise, good luck. I hope arithmetic sequences go well for you. Happy adding, and have a great day.